So now, before getting to this evidence that black holes actually exist in our universe, we'd like to start a journey from nearby. And by gradually going away from us, you're looking and farther away in the universe. But what that means also is that you're looking farther and farther back into the past. And that's the way we begin our journey back to the Big Bang. So let's start that journey. So thinking at something that is fairly nearby. So this is a picture of the International Space Station, where you can see the astronauts actually even working outside the space station. And these pictures are very impressive because that shows that the humans have developed to the extent that we can actually leave the Earth, get into outer space, and have even a station outside the Earth. But if you actually look it up, you find something which may be surprising to you. The International Space Station is floating above the Earth at the altitude of 375 kilometers. That's not that much of a distance, right? If you think of the fact that the diameter of the Earth is 12,000 kilometers, this is actually not very much. So if you think of the Earth, planet Earth, as let's say, a fruit, peach, then how much you actually move up to the International Space Station is only a skin depth of a peach. So you see, it's actually not very much. So that also tells you that moving farther away into the universe is actually not a very easy thing to do. You can send probes though, and of course people have managed to even go to the moon as well. So this video clip is showing the image of a space probe named Kaguya, which Japan has launched a couple of years ago. And what this probe has done is go to the other side of the moon and gradually come back. And while it's coming back, the Earth was in the shadow of the moon itself for a while, but then you start seeing the Earth getting into your view. So this is the Earthrise instead of sunrise. And you see the Earth is such a beautiful planet. Of course, we have to protect it. But this is a really impressive picture because of that. And now, just by thinking about how far away the moon is, it's actually 380,000 kilometers away from the Earth. Much, much farther away than the International Space Station. And because the distances we talked about in the universe are so big, we typically use time rather than the distance to describe how far away these objects are. Using light, it takes 1.3 seconds to reach the moon. So we say the moon is a distance of 1.3 light seconds away. As a matter of fact, the Apollo astronauts who have actually been to the moon placed a piece of mirror on the surface of the moon. We can send a laser light from the Earth, reaches the mirror in 1.3 seconds, gets bounced back to the Earth 2.6 seconds later. So that's the way we can measure the distance to the moon extremely precisely these days. Anyway, so this is the picture from this Kaguya probe. It's just a beautiful picture of our planet Earth. The object that is, of course, very familiar to us and very important to us, of course, is the sun. This is even farther away. It takes more than 8 minutes for light to reach the sun. So in terms of kilometers, it's 1.5 times 10 to the 8th kilometers. You can see this is actually a pretty far away object. But we see so much abundant sunlight from the sun because sun really radiates incredible amount of energy. So that's the origin of the warmth and heat on our planet Earth. And as we discussed earlier, the solar system consists of quite a few planets revolving around the sun. And we are actually the third planet, as you see in this picture, and that's the solar system. And again, to get some idea on the distance involved here, Japan has launched yet another probe called Hayabusa a couple of years ago, which managed to reach this asteroid named Itokawa. And when this object, Hayabusa, that's a space probe, eventually landed on this asteroid, Itokawa, it was a distance of 20 light minutes away from the Earth. So when the command center sends a command to this probe, it takes 20 minutes to reach it. And then Hayabusa was trying to land on this asteroid. It has to control its direction and speed, exactly where to land and so on. And then it sends back the information back to the command center. That takes another 20 minutes. And then sending a signal back would take yet another 20 minutes. That's not the way to do it, obviously. So this probe had to have this own control, the artificial intelligence on board that it could decide if it was going with the right speed, the right angle, to the right distance, to the right location on its own. So it takes that much time to send back and forth the communication signals to a distance even within our solar system. And if you think about even the farther away outer planet like Neptune, it takes 4 hours for the light signal to get there. So our solar system, as you can see, is already pretty big. And do you know what is the human-made object that moved away from us the farthest possible so far? That is a space probe launched by NASA in the United States already like 30 years ago, named Voyager. And it passed by planets like Jupiter and Saturn on their way and sent us very beautiful pictures of those planets. And they're still moving away from the solar system. Only this year, we learned that the Voyager has basically left the solar system and went even farther deeper into the universe. So where Voyager is now is 16 light hours away. And if you go to the NASA website, you can see the precise location of Voyager. We are still communicating with the probe, and the numbers of the distance just keep sticking up as you watch. So it's still in communication with us. And on this space probe Voyager, that we have put in, say, a metal plate that has the etching of the human drawings, human letters, some of the pictures, even CD recording music and so on, hoping that maybe one day an alien might be able to actually find it and send us a signal back that we found your stuff. And we're still waiting for that. But do you know how much that might actually take in the end? So here's the picture of the closest star where we might possibly hope that the aliens might be able to pick up this space probe. Voyager, here it is. And the name of the star is Proxima Centauri. And the distance to this star is actually a long distance. Even for light, it takes more than 4 years, 4.2 light years away. And the Voyager took 30 years to get to this distance of 16 light hours away. In order to get there, it will still take tens of thousands of years. So maybe we can't wait for the signal from an alien that soon, unfortunately. But anyway, so this is the closest star we can find around us. That's already several light years away. And we have many of these stars in our own Milky Way galaxy. And the Milky Way is named by the fact that the stars all lined up in a way that might look like a milk flowing. That's a Milky Way. And the reason why the stars look like this is because we're embedded into a disk of this Milky Way galaxy. And you might be actually surprised to hear is that we are not at the center of this Milky Way galaxy, but actually in a suburb out here. And in this galaxy, there are something like 100 billion stars, and we are actually located 28,000 light years away from the center of the galaxy. So that's, pretty far away suburb, and that's where we live in. And the shape of this galaxy is actually like this if you look at it from sideways. It's fairly thin. It's only 1,500 light years thick. And we are away, as I said, 28,000 light years away from the center. And because of the shape of this disk, we are here looking towards the center of the galaxy. Everything is inside the disk, and that's why the stars look like flowing along a river. And that's why we observe the Milky Way. So that's the structure and shape of our own galaxy. But because we are actually off-centered, it's like the Earth off-centered from the Sun. Our solar system is revolving around the center of the galaxy over many, many years. And this is actually going at an even incredible speed. It's actually that our solar system is moving at a speed of 220 kilometers per second. It's an incredible speed. But then you should ask the following question, right? If the solar system is moving so fast, why is it still kept inside our Milky Way? What is pulling us inside? What is the source of that strong gravity? Well, then you might ask the following question. Maybe there are objects like black hole at the center of the galaxy that's pulling us. That's why we can stay inside the Milky Way galaxy. So let's take a look into the center of the galaxy. So this is the video showing zooming in towards the center of galaxy by using powerful telescopes. You see a lot of this black stuff. They're actually dust. And dust is not really black. It's just that it creates a shadow that we can't see the stars beyond them. But using something called infrared light, we can go around that dust and see what's beyond it. And we can observe the motion of stars at the center of galaxies. And just watch this star. It goes like, quick, like quick, right? It's being pulled towards something, gets accelerated, and then once it actually gets very close to the center of the object here, goes like this one here, quick. So it's clear that something very heavy is pulling this star, gets accelerated, and after it passes through, goes back also very quickly. So this is the cleaned up image by using computer processing. So what you have to do is watch the motion of these stars over like 20 years. It takes that long years for these stars to orbit around this very heavy object. And by studying the motion of these stars, you can even determine how massive the object is. Just like we could determine the mass of the sun by using the force of gravity that's keeping us around in the elliptical orbits around the sun. And the answer turned out to be staggering. This object is 4 million times heavier than our sun. And nothing can be that heavy except for a black hole. There is a black hole, supermassive black hole, at the center of our Milky Way galaxy. So there's the black hole. And that was discovered by many people. And this is one of my colleagues, Reinhard Genzel, working at Berkeley. And so they determined the mass of the black hole, as I said, is 4 million times the mass of the sun. And if you observe other galaxies beyond our Milky Way galaxy, some of them have even heavier supermassive black holes, as heavy as billion times the mass of the sun. And as we talked about before, black holes can swallow things, but nothing can come out of it, because even the speed of light is not enough to escape the force of gravity from the black hole. So if a black hole swallows things around it, it falls into it and it would never come out. Even light does not come out from it. You can never see it anymore. But just before gas might enter the black hole, it gives us the last word. It likes a scream. Ah! It lights up. And you can actually observe that. So if you observe this video here, and if you look closely at the location of the black hole, sometimes it just brightens up a little bit, and like 30 minutes later, it fades back down. So that's the last word we hear from the gas falling into the black hole. But now that we have learned that this black hole is 4 million times heavier than the sun, that sounds an incredible mass, but we also learned that our solar system could not be bound to our Milky Way galaxy by the force of gravity of 100 billion stars, right? So even a black hole as heavy as 4 million times the sun wouldn't be able to keep us inside the Milky Way. We still need more mass to be kept inside our solar system. What do you think that could be? So that's the subject of the next discussion.